And all right, so good morning or good afternoon, depending on where you're joining us from, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants, and we are all about bringing conservation, adventure, and science into classrooms around the world. Today, we've got a little bit of all three, which is very exciting. Right now, we're joined by 4 classes from across North America. I'm going to give them a chance to do a bit of a shout out before introducing our speakers. We've got Miss Carton's grade 5-6s in Anchorage, Alaska, just pouring in at the beginning of the school day. Hi! The one student who came in and just feels awkward. We've got Miss McGuire's grade 7s in Severn, Ontario, joining us for the first time. Hi, guys.
Hello.
Someone turned the lights in the room, too, made it even better. We've got Miss Biffords, grade 3s in Calgary, Alberta. All the lights at the back of the room. And we've got Ray Goodman-Luckers, grade 8s in Oakland in California. Hi, guys. Hey. All right. Of course, the reason you guys are all here today is for our speakers. So we are joined live from the RV Falkor off the Pacific coast of North America, coming into Mexico territory now. And so in 2015, the Monterey Bay Research Institute went out and found some really, really neat stuff at the bottom of the ocean. And so the Falkor, through the Schmidt Ocean Institute, is out to investigate even more, send some robots to the seafloor, and find out what they can discover. Without further ado, I'm going to turn it over to the Falkor. Monica and Becca, thank you so much for joining us, and take it away, guys.
Hi, I hope you can hear me okay. Thanks so much for joining us. As was just introduced, we are broadcasting to you live from the Pescadero Basin, which is in the Gulf of California. We are on the research vessel Falkor. My name is Becca Shepard. I'm a science educator and a geologist. And my lucky job here is to, first of all, corral some of these busy scientists, make sure they give some time to talking to you to tell you about what we're doing. And then I'm also here to help turn all this brand new research into activities that will be available for students like you guys to learn more about what we're doing. So without further ado, we're going to jump into the science. I'm very lucky to have standing next to me Dr. Dave Caress. He is the principal engineer of seafloor mapping at the Monterey Bay Aquarium Research Institute. So I'm going to turn the mic over to him, and he's going to tell you some of the brand new science that we've been doing here.
Thank you, and good morning. As was mentioned, 3 years ago, our institute, in a 2-ship expedition, discovered some hydrothermal vents, a hydrothermal vent field on the seafloor in South Pescadero Basin in the Gulf of California. And the way that this happened was that we used an autonomous robot mapping the seafloor in high resolution to map areas that had never been investigated before. And we recognized features on the seafloor that were of interest. And 3 weeks later, a robot that is tethered and interactive, a remotely operated vehicle, was sent down to these places, and the vents were discovered. Coming back here this year on the Falkor, on this vessel, we once again used submarine robotics to do a couple of different things in preparation for the cruise that's underway right now. And that is, for the previous 2 weeks, we were using robots to map the seafloor in the place that we previously discovered in much higher resolution. And at the same time, we were mapping other areas around here, looking for additional hydrothermal vent communities. And we've got some, we have some slides to show you what some of these robots look like and how we're using them. Here's the Falkor. That's the ship that we're on right now. I have to tell you, it's a great ship. I've been on a number of vessels over the last 30 years, and this is a really comfortable ship to try and work on. Here's a view from the fantail of the ship. That's the back of the ship that we work from. What you see are 2 robots. In the foreground is a torpedo-shaped robot, that's an autonomous underwater vehicle. It swims off by itself. So it just has a single propeller at the tail. It's carrying a bunch of sonars that are used to map the seafloor at about 1 meter resolution, which means that even if the seafloor is 3,700 meters deep, we can map the presence of a feature that might be the size of a table. And could you back up one slide? Yeah. So then that's the torpedo-shaped robot, the underwater, or the autonomous underwater vehicle. We load a program into it, and it flies a mission that we have defined. In the background, you see a bunch of engineers working on a remotely operated vehicle. And so that's a robot that goes down, that is connected to the ship and to a control room by a tether. We send power and communications and commands down the tether. We get data and video back through the tether. And it has manipulators and sensors and a variety of different equipment on it that changes depending on the mission. And very shortly on the cruise that we're on right now, the biology team is going to be using that robot to investigate the animal communities that live around these hydrothermal vents where extremely hot water comes out of the seafloor. Over the previous 2 weeks, we went out with mapping equipment attached to that vehicle that let us map the seafloor of areas about a football field size in a day at 1 centimeter resolution while taking photographs of the seafloor. So when we put out the AUV and it swims off, it goes off for about 20 hours. And we can track it with acoustics at some level, but really it's off on its own, and we go off with the ship and do other things, usually diving the ROV. And then after 20 hours, it swims back to the surface, and we have to go find it. And this picture shows the Mbari AUV group leader, Hans Thomas, holding a radio direction finder out looking for the AUV in a small boat. So when we get the AUV, when we find the AUV, then we have to get lines onto it, and we tow it back to the ship, where we use a crane to pick it back up onto the fantail of the ship. It will then take us about 6 hours to get it ready to go on for another 20-hour mission. And that's picking it up out of the seafloor. It weighs about 1,500 pounds, and it's a real delicate maneuver to bring it aboard a moving ship. Now this is the mapping equipment on the ROV Sebastian. What you see in the foreground, the two steel cylinders, they're actually titanium cylinders with the green lettering on them. Those are laser scanners. That's what's called a LiDAR, or laser ranger. And that's the sensor that we use to give ourselves centimeter scale topography. And then also on that the same package, along with that LiDAR, are sonars and cameras that let us also map the seafloor, taking pictures as well as getting sonar-based bathymetry. Okay. And this is the underside of that. So you see at the top, the underside of the two laser scanners. That's the glass windows. They're actually sapphire windows to withstand the tremendous pressure at great depth. And the lasers shoot through those windows. And then the round thing with the little round windows on it, that's a sonar. That's called the Doppler velocity log that we use as part of our navigation system. Okay. So here's ROV Sebastian getting lowered into the water. And then here's the control room. Again, an ROV is connected back to the ship through a tether. And we have ROV pilots that fly the vehicle and also run all the manipulators and other equipment on the vehicle. we have a navigator, and then we have all the scientists that are working. Okay. Here's a view of our team on the fantail with the AUV after we've got it back from a mission. All strapped down and ready.
We have the photos of the map, or we can go to the control room, wherever you
prefer. Let me just do the bathymetry now. Okay, so this just is an example of the mapping that we've done. In this case, this is the map done from the ROV, and what you're seeing, the red parts are higher or shallower than the blue parts, and so those are places that stick up above the rest of the seafloor. The map that you're looking at is about 200 meters across, or about 600 feet across, and the resolution of the features that you see in this version of the map is about 5 centimeters, or about 2 inches. And all those mounds that you see and all the sharp features that you see are hydrothermal vents, places where hot water is coming out of the seafloor and supporting these very unique communities that the biologists are about to investigate. And what this map is going to allow the biologists to do is to use the ROV to go to exactly the right spot to see the animals and study the animals that they want to, and to understand the broad set of different communities that live here and what lives where.
All right. So we're going to try and give you a special treat here and take you actually into the ROV control room, so you can see exactly where the ROV pilots pilot the vehicle. Bear with us. We're actually going to have to carry our setup across the hallway, but we'll try and get you in there so you can see that. Hold on just a second.
So just to clarify, they are on a ship right now, and they are moving from the library, which is where they usually give the presentations. They're moving across the hall to the control room, which, as the scientist mentioned earlier, the control room is where the robot is connected. So this is what we're going to see, is some screens that actually show exactly what the robot sees when it's underwater.
All right. Welcome to the ROV control room. Hope you guys can hear me okay. You'll notice we don't have a lot of people in here today, if you can kind of pan around the room. That's because we're actually having some pretty high winds today. We were hoping to put the vehicle in the water this morning, but instead, for safety, right? Remember, we keep that ROV tethered to the ship. So if we have a lot of wind and a lot of swell, that's really dangerous to have the vehicle in the water. So instead, for safety, we're waiting. We'll check again, hopefully to get that vehicle in the water this afternoon or tomorrow. But that gives us a great chance to show you what it actually looks like. So let's see if we can get that camera up actually on the control room. So this is where an ROV pilot sits. You can see this is how they actually control the vehicle. Look behind the chair there. Ah, perfect. Ah, it's stuck. You'll notice our chairs are real sticky because, of course, we have a little bit of motion on the ship, even in relatively calm conditions. It's a very digital setup. Kind of like flying a vehicle through space, to be honest. That's what you should imagine with all the panels. It takes a lot of tech. In fact, I'll ask, would you like to share some of the details about actually driving these vehicles?
So what happens is the pilot that sits here actually flies the vehicle, and these controls are what control the thrusters. And then the pilot that sits in this chair will manipulate these controls here. These run both of the manipulator arms. And just a couple days ago, I was watching a pilot named Chris pick up a rock off of the sea floor where it was very soft mud, the geologist wanted a particular rock, and Chris had to, watching the video displays from 5 different cameras looking in different ways, he had to use that control. When he dropped the rock fell, went under the mud, and he had to use a manipulator to go root around in the mud and feel for the rock, and he got it. And it was exactly the rock that the geologist wanted, the sample that he needed to understand how the seafloor is made in that spot. Over here sits the technician that is the navigator. And this person is controlling the sonar that we use on the ship to track where the ROV is and relate that position to the maps that we've made. And then up here, we'll see when the ROV is in the water, on that map, the ROV will show up as an icon telling us where we are.
That's great. Okay, now we want to make sure we leave you plenty of time for questions. So we're going to take you back across the hall to the library where we can hear you a little bit better. So follow me again.
You're back. You're gone again. They'll be back in a second.
All right.
There we go.
Are we back? There we go. Welcome back to the library. You may have seen some of our other scientists around the room waving at you as we came in. All right. Bring on the questions.
All right. So first, let's go to Miss Carton's class in Anchorage. If you guys have a question, come on up.
Okay.
Yeah.
All right. Go ahead.
How much longer until people can go to the seafloor?
And then at the same time, we don't know what hydrothermal vents are necessarily, or I guess why they're important. So I didn't know if that could be something.
Yeah.
You want to take that one?
Sure. Hydrothermal vents are remarkable because they support really unusual life in the. Thank you.
Yeah.
So what's really special about the hydrothermal vents is that they're releasing into the water, bringing up into the deep ocean a chemistry that's capable of supporting really unique forms of life. Up where we live on the surface, most of our ecology, most of our life is driven by energy from the sun. Photosynthesis that the plants use to make sugars, to make food, that then feeds all of the other life. And in the deep ocean, that photosynthesis can't occur because there's no light in the deep ocean, or very little light. And so for the most part in the deep ocean, the life lives on food that falls down from the surface very slowly, and there's not much food available. But we find these special places where there's a huge amount of different animals living on the seafloor, and it's because the hydrothermal vents, these volcanically driven places where intensely hot, very mineral-rich water comes rushing out of the seafloor, and there are bacteria that can live off of the chemistry coming out of the vents, and then there are animals that can live off of the bacteria, and so they're important because they support really unique communities.
Great. Yeah, and when he says hot, really, really hot. Hydrothermal vents are places where seawater that's been heated by basically underwater volcanism, it's been heated and it's coming back up into the ocean through the seafloor. And we're talking 200 to 300 degrees Celsius. Okay, I'll challenge you to look up what that is in Fahrenheit, and it's going to blow your mind. I want to make sure we didn't miss that first question. I had a little trouble hearing. I think it was how long till we can send people to the seafloor. I think Dave knows more about this than I do. Yeah, oh, excellent. I see a thumbs up. So we can send people to the seafloor in some places, and with a lot of tech to really quite deep places, but it depends on what you want to try and accomplish there. Do you want to address that a little bit?
Sure. Actually, the deepest spot in the ocean is the Challenger Deep in the Marianas Trench in the Western Pacific, and people have been there. Two gentlemen, Don Walsh and Jacques Picard, I think, went there on a submersible called the Bathyscaphe almost 60 years ago. And I've met Dr. Walsh. He's a very great guy. But people have been to the very deepest part of the ocean. But when they went there, all they could do was to look out through a very small window and with a little bit of light and describe what they saw. And so it's very possible to send people deep in the ocean. What we're finding for the kind of science that we're doing, robotics that are unmanned are more efficient and more capable. And so in this case, we're going to send the ROV down, as we did last week, and everybody on the ship is going to be able to participate in that dive by being in the control room or one of the other rooms that are wired in with the same video displays. And in fact, people all over the world can participate in the dive because they can watch the video feeds as well.
Cool. All right, next question.
Yeah, just really quickly, before we go to the next question, I also want to note that we've got quite a few groups watching on YouTube Live. So if you're watching live and you want to type in your question in the chat bar, I can pass it on to the speakers on the Falcor. So please do that. One quick follow-up on the hydrothermal vents. We know they're really hot. What do they look like? What is this actually, when you drive up to a hydrothermal vent with a robot, what are we seeing?
If you want, we can show the screen.
Yeah, let's pull up a picture for you. How's that sound? While she gets that arranged, I'll give you a little teaser. First, that's actually a great question because hydrothermal vents can look like a lot of different things. One of the reasons we're here in Pescadero Basin is that these vent fields are actually pretty different than vent fields that have been discovered before. In fact, you might have seen pictures of what scientists call black smokers, which are places where those hydrothermal vents, those waters coming up, are precipitating dark colored minerals. Here in Pescadero Basin, we're going to show you some pictures of some chimneys, and they're actually made of lighter colored minerals, anhydrite and carbonates, right? So they can really vary. Yeah, bring on the pictures. See if we can show you some. Okay, we've got some live video. You want to narrate for us?
Okay, well, these are hydrothermal vent chimneys. This particular chimney, you can see the shimmering water coming out of the top of it. That's because that water is so hot. We did measure that water. It's 287 degrees Celsius. This is another place. Here, that was a place where water was pooling upside down in a dome. Here are tube worms living off of the hydrothermal fluids coming out. Those tube worms host bacteria that provide them their food, and they exist in the hot water, not directly in the vents, but quite near to the vents. And there again, you're seeing more of these different types of tube worms. And then there are all kinds of animals that you can find in there that are living off of the tube worms or near the tube worms and off of the bacteria also living there.
Do we have a question on chat?
Okay. Sounds like we've got a question coming in on chat.
How much time do you spend on board?
How much time? All right, so we of course, or do you mean on board the ship, or how much time do we operate on the vehicles? So we'll do both of those. On board the ship, that's a different answer for different members of the team and in this room. Dave has actually been on board since
October 31st. So.
October 31st. So he's going to be on board almost a month. Most of the rest of the team on this leg actually just got on board this weekend. So we'll only be on the ship just under 2 weeks. So it really varies depending on that schedule. And then in terms of the vehicle, we are currently operating the ROV on what we call 12-hour dive days. It actually takes a really long time to get that vehicle all the way down to the bottom and all the way up. So it's only on the bottom for 6 to 7 hours.
Excellent. All right, let's take a question from Miss McGuire's group. Do you guys have a question?
Yes, we do. Greg, you want to come up? Can you hear us okay?
Yep, we're great.
So you mentioned water like hot. What would animals have to do adapt and evolve to be able to live in those areas with the hot water?
Okay. Let me repeat it back just to make sure I heard your question right. We have really hot water, right? So what do the animals have to do in order to be able to survive there? I want you to know you are getting double thumbs up from one of our seriously awesome biologists because she loves that question.
Not only that, we're going to let her.
I was going to say, we're going to pull up the specialist. Here, come over and answer this question. I shouldn't do it when we've got one of the specialists in this.
The double thumbs up.
Hold on just a second. We're going to get you the expert.
I'm not filming.
Yes, you are. That camera.
Okay, that was a great question. This is Shauna Gofreddy from Occidental College in Los Angeles. The animals themselves actually don't encounter temperatures that high, but they are in some cases in hot water, and they do adjust their membranes, their lipid membranes around their cells, and some other features of their enzymes to accommodate those high temperatures and high pressures, actually, which is also another issue with living in the deep sea. So it was a great question. They are all exquisitely adapted to their environments down there, and they would actually find our habitat rather extreme to them. So they wouldn't be able to survive where you're sitting here. So that's a great question.
And
Careful, questions like that, you'll get recruited.
I wanted to add just another aspect. Even though the water that's coming out of the vents is extremely hot, the water right next to it is extremely cold. Like she just mentioned, there's a lot of pressure down there. So it's not like there's a very big gradient or space where it's kind of medium in between. It's extremely hot, and then just millimeters away, centimeters away, not even inches away, it's extremely, extremely cold. So that's another reason why these animals are so specialized to live in such a strange and extreme environment.
Excellent. All right. I wanted to note, too, that the question that came in online was from our class, our Julia Morgan School in Oakland. So if you guys, I know you've been having trouble with tech. If you want to keep typing in questions that way, we will pass them on to the Falcor. That's great. For now, let's go to Ms. Biffert's class in Calgary. You guys have a question? Come on up.
Yes, we do.
Perfect.
What would happen if the ROV lost power in the middle of its mission?
That sounds like a question for our technical specialist over here.
It happens. And it's very uncomfortable. It's what we call a dead vehicle recovery. And the thing is that the tether is extremely delicate. It has fiber optic glass fibers that we use to do the high-speed communications through, and glass doesn't like to get stressed too much. So we try and be very careful with our tether. But if we have a dead vehicle recovery, all we can do is pull the vehicle up on that tether. And then when we're recovering the vehicle, the pilots drive it to the right place. If the vehicle's not powered, then you're yanking it to the right place. It becomes really really dangerous, even if it's happening in rough weather like we have today. And that's part of why we're not in the water today, is that if something goes wrong, it would not just be uncomfortable, it would actually be dangerous. So we actually have to deal with that. The pilots and the ship's crew are very skilled and they know how to, but they do not like it when it happens.
Great question.
Yeah. All right, we had a class join us about halfway through the hangout. So we have Miss Reeves, grade 3-4 from Leamington in Ontario. And I won't be able to demute your mic, so you guys have to come up in the little microphone symbol at the top of your screen. But if you want to do that, you'll be able to ask a question. So come on up. We'll let you know. Oh, you're not good yet. You still got to demute your mic, okay, guys? So for the teacher to come up, little microphone symbol, top of your screen, and when that's clicked, then we'll be able to hear you guys. Almost. You're good.
What inspired you to do that? Like, what inspired you to like do what you're doing?
You want to go first?
When I was your age, I wanted to be a scientist, and I still wanted to be a scientist when I was in college. And all that time, I really had no idea what sort of scientist I wanted to be. When I was in college, I would spend time in the library reading different journals, and it just happened that the articles that interested me the most were about the seafloor. And so that's what I went and did.
And for me, when I was 10, I decided that I wanted to be an astronaut and go into outer space, because there's nothing cooler than getting to explore everything around you. And that's kind of what I've been chasing ever since. Funny enough, it turns out that exploring the ocean is actually a lot like exploring outer space for more reasons than I have time to tell you about all of them today. And so I actually ended up falling in love with exploring the ocean, because it's actually one of the ways we train astronauts, first of all, but it also turns out it's got just as many unknowns, really. We've hardly seen a tiny fraction of the bottom of the ocean seafloor. There are actually planets in this solar system that we probably have a better idea of what's on their surface, because seeing the bottom of the ocean is tough. There's all that water in the way, right? So I just love finding new things, and that's what these folks are doing. That's what I love to surround myself by. He doesn't make a big deal of it, but those maps, some of those places we are seeing through the eyes of those vehicles for the first time. No human had seen that stuff on the seafloor. I have a gaggle of biologists over to my right who are finding brand new organisms, right? Who knew that was even still a thing? There's still tons to be discovered. So that's what got me started, and it's what keeps me going.
I love the enthusiasm. All right. Now, Ray's class, the text's been working for a while now, so if you guys want to try in Julia Morgan School to try and do a question, you're welcome to. I'll come back to you guys in a minute if you want to try demuting your mic. If not, you can just write it in. But let's go back to Miss Curtin's class. Come on up. Everybody has a question.
I know.
It's a good problem to have. Right. So yeah, go ahead, guys. Whatever you want to ask.
Okay. Come on up. Is there a certain place you guys put the vessel, or do you go all over the ocean?
That's a great question. That sounds like one for you.
Okay. This particular research ship is operated by what's called the Schmidt Ocean Institute, and it does not have a home port. This ship just spends its time going around the world, and new science parties come on to do different projects in different places, and pretty much every 3 or 4 weeks. So right now, this ship is allowing us to do this science in this place in the Gulf of California. In a couple of weeks, the ship is going to be working off of Costa Rica, off of Central America. Looking forward, I think in years to come, it's going to be back in the Western Pacific and really pretty much going all around the world. And where it goes will be determined by the proposals that different science groups propose. Yeah. So it's limited only by their ideas.
Yeah.
thanks to the Schmidt Ocean Institute.
Yeah, that's great. So you'll find that scientists chase where the new science is, what questions they think they can answer. So they're going to go to where they think they can have the best chance of solving some of those riddles.
Outstanding. All right, let's take another question from Miss McGuire's class. Hey, guys.
Brayden, do you have another one?
Yeah.
Yeah. Okay. Yep.
Sorry, I can't.
All good. I can hear you. You're good.
There we go.
Hi, it's me again.
Hello.
How much percent of the ocean floor has been explored? Because you said we know more about some planets in outer space than we do about some of the ocean. So how much percent of the ocean's been explored?
I like it. I like it calling me for the real numbers. That's what I want to hear. I'm actually going to refer to all the experts surrounding me to get an actual number. What do you guys think? How much of the ocean floor has been seen? 7%. Scientists estimate between 5 and 7%. And when I say scientists, literally it's now sort of the people in this room. Between 5 and 7%. I'd say that's a pretty good ballpark. If you used Google, you would find something fairly similar. It is a hard thing to estimate, right? But yeah, I think that's a good ballpark.
Yeah.
Which, if you do the math, that leaves a lot left to be seen. So if you guys want to study the ocean, there's some job security there.
Outstanding. All right, let's go to Miss Reeves' class again. I can leave you now, so you're good to go. Whenever you're ready.
Hi.
Mike, turn the mic on, please.
Hi. I'm Lucian. How deep is the water? How deep is the sea?
How deep is the sea? Well, I'll tell you what, it depends on where you are. So we'll start with where we are. Where we are, correct me if I'm wrong, we're sending the ROV down to about 3,600 meters. Now, you might not be used to thinking in meters, so that's more like 11 to 12,000 feet. Is that right? And if you're used to thinking in miles, we're actually about 2.2 miles down underneath the ocean. I'm going to let Dave here tell you more about how deep the ocean is in general.
The deepest spot is just over 10,000 meters deep. And again, in the Challenger Deep in the Marianas Trench. Much of the oceans, if you were, say, around Hawaii but away from the islands, it's about 6,000 meters deep. Mid-ocean ridges that run through the central part of the Atlantic Ocean along the eastern Pacific tend to be at about 2,500 meters deep. And then basically the ocean is deep anywhere away from the islands and the continents.
Yeah, and you might remember one of our biologists saying earlier that with depth comes pressure. So if you want to think about it to blow your mind a little more, I can tell you that at the depths we're working at that 3,600 meters, right? If you went down there, you would not be happy, but you would be feeling more than 300 times the pressure you feel on you right now from the atmosphere. So you're not used to thinking of the atmosphere as putting pressure on you, but it is. But imagine 300 times that. It would get squishy.
That was a very polite way of saying you'd be turned into a little tin cube thing. Guys, we're almost at the end of our hangout, so what I want to do is, if you guys have any last messages for the classrooms, any way that they can learn more about the project that you guys are doing, become marine scientists themselves, anything last you'd like to share?
Oh my goodness, did you catch all those?
No pressure.
Okay, how you can follow along, right? How they can become marine scientists. What was the third one?
Just any last messages.
Any last messages? Okay, great questions. Well, you can definitely follow along with this cruise in a lot of places. Your keywords are the Schmidt Ocean Institute. If you check out their Facebook page, their Twitter, their Instagram, or even their website, you will find live blogs, videos, updates, all kinds of stuff. So definitely follow along with us on social media. If you want to become a marine scientist, that's a big question. but it's actually not that hard. Follow what you're interested in. Keep studying in school. Find ways to get involved. There's lots of ways probably around you that you can learn more about the ocean environment. You might even be able to get involved and do some conservation work. You might be able to help clean up our oceans. Find opportunities to take classes in what you're interested in, and you'll get there if you really want to do it. Yeah. Got any final words or anything you want to add to that?
I'll just throw out something for the mate competition. If any of you are interested in marine robotics, there's actually a competition in building ROVs that's put on by an organization called MATE, or Marine Advanced Technology and Education. And they have regional competitions all across the country, and actually in all across the world now. I think it's very much an international thing. So if you are interested in that, you can search online for MATE, ROV competition.
Great advice. Yeah, definitely. In this day and age, Google is your friend. If you get interested in something, look it up on the internet and add on opportunities for students, right? And you'll be amazed at the sort of things you can try and get involved in.
Outstanding, guys. Well, at the end of every hangout, what we do is I'm going to demute the microphones of Miss Carton's class, Miss McGuire's class, Miss Reed's class, Ray's class. If you guys can join me in saying a big thank you to the team at the RV Falco for joining us today. So thank you so much, guys.
No.
All right. All our classes will be doing more hangouts with the Falcor throughout the year, other marine research institutes. And we look really looking forward to being back soon, okay, guys? All right. Thanks to the Falcor, guys. Bye.
Thank you. Thank you.